All right, guys, today we're moving on to 5.2a, zeros and relative maximum or minimum. Our I-can statement today says I can determine the zeros of a polynomial function, including its multiplicity, and identify the relative maximum and or relative minimum values. That sounds like a mouthful, but actually a lot of this is going to be kind of easy for you, I think, just because of the fact that we've already been through a lot of this when we're talking about quadratics. Only difference is we're just moving up a little bit higher with our exponents, moving up on our indexes up to higher indexes, but it's okay. It's going to be the same exact thing as well. So let's start out here with the pretty simple problem. Let's just say x squared plus 2x minus 3 equals 0. So you notice this time I'm given a quadratic function, and I'm told to figure out when that quadratic function equals 0, okay? And if you think about it, when you graph this, this is just basically showing you where it's going to cross the x-axis at. And so what would we do here? First of all, I noticed that there is a 1 right here, which means that I may be able to factor this. So let's think about the factors of 3, which is pretty easy. It's just 1 and 3. But notice here I'm using subtraction. So I've got to subtract 2 of these numbers to get a positive 2. Well, it just so happens that I can take 3 minus 1 and get 2. So this 1 would have to be negative right here. And so I could actually factor this out into two binomials. So I could factor it out into x minus 1 times x plus 3. And again, if you needed to think about, well, is that really the same thing? Well, you could FOIL this back out, and it should come up to exactly this same thing. And it does, as a matter of fact. But again, what I wanted to show you is now I've got this in a place and position where I could actually figure out what these zeros is. And so notice what you would do here is you would take x minus 1 and set it equal to 0, and you would do x plus 3 and set it equal to 0. You take them each separately and just set them equal to 0 to see what the zeros of this function is, okay? So at this point, all I need to do is I just need to add 1 to both sides on this one, and I need to actually subtract 3 to both sides on this one. So notice what happens here. I'm going to end up with x equals 1 here and x equals negative 3 here. So you remember we started with x minus 1 equals 0, and we ended up with a positive 1. It's basically just the opposite of whatever I had here. As well, here I had x plus 3 equals 0, but I ended up with x minus 3, okay? So your zeros that you end up with are basically just the opposite of whatever you came into the equation with, okay? So x equals 1 and x equals 3 would be the zeros of that particular function. Well, that's basically what you're doing here. Is they're going to go ahead and give you these binomial factors like this, and you're just asked then to figure out what the zeros of that would be. Let me give you one such example here, and maybe this one will take us to a little bit different level. So if we had y equals, we'll just call this example 1, y equals x times x minus 2 times x plus 5. And we were asked to find the zeros, okay? Find the zeros of the function. If I were to multiply all this out, I'm actually going to get something that's x to the third, and I'm not going to make you do that, okay? But again, what did we do up here to try to figure out what the zeros were? We basically just set every one of these terms equal to 0, okay? So I would have x equals 0. That one's pretty simple because it's right there. I would also have x minus 2 equals 0. And x plus 5 equals 0. And again, on this one, I'm kind of already done, so that's part of my answer already. But here, I'm going to have to do some math. I'm going to have to move the 2 to the other side. So notice what happens. It just becomes x equals 2. So now we kind of realize, okay, if this is x plus 5 equals 0, what's going to happen? It's just going to be the opposite of that. So it's going to be x equals negative 5. So ladies and gentlemen, all three of these would be my answers that would make this 0. Now, you may be thinking to yourself, wait a minute, you're telling me that x equals 0 and 2 and negative 5. Well, matter of fact, it would, and let's just kind of put one back in and you'll see what happens here. So if I put 0 in right here, and then I multiply it times anything else, well, what's it going to be? It's going to be 0, okay? Conversely, if I take this 2 right here, and I put it in right here, I'm going to get 2 minus 2, which equals, you guessed it, 0. And if I take 0 times any of these other two things, guess what? It's still going to be 0. And likewise, last but certainly not least, if I take this negative 5 and I put it in right here, negative 5 plus 5, I'm going to get, yes, once again, 0. So either one of these three answers is going to give me a 0. So that means x could equal 0, x could equal 2, or x could equal negative 5. Either way, if it's either one of those three numbers, then this thing's going to end up being y equals 0, okay? So that's basically all you're doing for this first part. Now, the next part is about this big word called multiplicities, okay? So it may thought, well, what in the world is a multiplicity? Well, again, notice that this number 0 just happened one time. This number 2 just happened one time, and the negative 5 just happened one time. But what if, just think for just a second, what if I had y equals x minus 5 to the third? Well, I could rewrite x minus 5 to the third as x minus 5 times x minus 5 times x minus 5, right? Because this 3, this exponent tells me how many times I'm going to repeat this base, and I'm going to have multiplication in between. Just like 2 to the third is the same thing as 2 times 2 times 2, okay? So x minus 5 in parentheses to the third is the same thing as this. Well, I'm going to get an answer if I take one of these and I do x minus 5 equals 0, and I add 5 to both sides, I'm going to get x equals 5. But how many times am I going to get x equals 5? I'm going to get it once here. I'm also going to get it again here and again here. So how many times am I going to get the answer x equals positive 5? Well, I'm going to get that answer 3 different times, okay? And look here, that's exactly what my exponent is, okay? So your multiplicity is basically just the exponent that this is being raised to. So for an example answer for this one, my x would equal 5, okay? That would be my answer, but it would have a multiplicity of 3. In other words, you're saying, I'm going to have x equals 5, but that's going to happen 3 times, okay? So that's basically all you have to do on the multiplicity part. So the next part is actually, again, quite simple, something we've talked about before. Maybe you just didn't think about it in this context, is we've talked about maximums and minimums before. So let me give you just an example here. So if I had y equals x squared plus 1, okay? So just think about what that graph would really look like. I would have the graph of x squared, but remember this is a vertical translation, so it would be translated up 1 unit. So it would look something like that right there. So my question to you would be this: would this have a maximum or a minimum? Now you notice these ends, they're going up forever. They go up toward infinity, okay? So I don't really have a maximum, but I do in fact have a minimum right here. There's a bottom to this thing, okay? And where is the bottom? Well, remember that bottom is always whatever my y value is. And so we know that because this is my y-intercept, it crossed at positive 1, that I know that I have, in fact, a minimum at y equals positive 1, okay? So that kind of makes sense. Conversely, if I had, for example, y equals negative x squared plus 2. So in this case, I don't know what I just did. In this case, I kind of have a graph that looks like this. Again, notice on my end behavior, I'm going down forever in both directions. But I don't really have a minimum value, but I do in fact have a maximum value right here. Okay, this is the furthest this graph is ever going to go up this way. And so what is that value? Well, it's kind of laid out right here for us, right? Positive 2. So again, in this case, I would have a maximum. Let me do that in red since I did the other one red. I would have a maximum at y equals positive 2. So then the question becomes, okay, what if you have something like, what if you have something like y equals x to the third plus 4x squared minus x plus 1. Well, again, just talking about end behavior from yesterday, you remember that since this is a positive number here, and since this is odd, right, that I'm going to have a graph, and I'm just going to just draw it rough right now. It's going to look sort of like that right there, okay? I'm going to have a graph that looks like that. Well, do I have a maximum or do I have a minimum? Well, I don't really have, notice, again, looking at my end behavior here, I've got, well, this goes on forever this way, so that's really infinite, and this goes up this way, so that's really positive infinity. So I don't really have a true maximum or a minimum. But what I want you to realize is I do have a relative maximum right here, and I have a relative minimum right here. Okay, so when we're talking about relative maximum and minimum, what we're talking about is that point where it reaches its lowermost point other than the one that goes to infinity, and I'm talking about the uppermost point where it almost gets to infinity. Well, how in the world am I going to figure that out? Well, it just so happens that you have a great tool called the Desmos graphing calculator. Okay, so you could take this equation just like it is, put it into Desmos, which I have already done for you here. This exact one that I wrote down as your example, I've already got in here. And notice what I can do with Desmos. I can go in here and I can plot out what that minimum and maximum value is. And look at there, it's already trying to help me find it. Actually, there it's trying to help me find the y-intercept, okay, as well. But you can kind of see where the bottom of this is. And so this would be my relative maximum, okay? And you can round these to say the nearest tenth. You don't have to go out as many decimal places as what they have here. So for example, this would be negative 2.8, okay? Negative 2.8 and 13.2. So again, on this one, we would say that it has a relative maximum. Let's get those numbers again real quick. Has a relative maximum at negative 2.8 and 13 point something. Let me get that again. 13.2. So that would be the relative maximum of that particular graph. And again, our relative minimum, we're just going to get that right from our graph. Relative minimum is 0.1, let's say, and 0.9. So 0.1 and 0.9 would be our relative minimum. So notice you've got two ordered pairs here. And if anything has, for example, x to the third, then you know already that it's going to have two terms. So it is going to have both a maximum and a minimum. Okay, as a matter of fact, the examples you're given, they're all x to the third. So you're going to have both of these. You just got to figure out which one's which. Okay, so hopefully this has been helpful. And again, not really anything super new. Maybe just a little bit new from what you've ever seen before, but really familiar with what you've already seen with quadratics. So should be able to do very well on this. Again, guys, if you need any help, just reach out to either me or Miss Wheeler, and we'd be glad to get in touch with you. Thanks.